better now.
Okay, let's see if there's something there. Madeline, we're ready to go?
The teams have 5 short nights to find out how much the black hole is eating by measuring the energy that flares out.
Zoom in a little bit more. All right, so first night. Doesn't look like we've got any flares.
Chandra headquarters in Cambridge, Massachusetts. The first night turns up only noise.
4 more chances, guys.
Night 2. Chile has problems.
No, we have to redo the acquisition over.
Even if there are flares, the Chilean telescope can't see them.
It was the correction was,
Unstable.
yeah, unstable.
A patch of humidity is confusing the computers. The crucial adaptive optics aren't working, and everything's a blur.
Extremely.
Okay, now we have a problem with the 8 meter, with the main mirror. The 8-meter mirror seems to be deformed.
In Hawaii, it's not much better for Gez and her team. The Galactic Center is playing hide-and-seek behind overcast skies.
We're fighting with clouds. It looked better just a moment ago, so it looked like we were just ready to go, but now it's looking like yuck.
The Hawaiian forecast predicts even more clouds tomorrow. The team is getting anxious. Finally, on night 3, the German team's luck changes.
Very in correction.
Look at this.
Right.
Yeah, it's really flaring.
In Chile, they spot an outburst.
That's the best flare event that we saw during this run.
Definitely.
A new point of light appears in the star field, one that wasn't there before.
Very nice, very nice.
Here we can clearly see a region between those 2 sources where there is no other object. And here we have the same region, the same 2 sources, and now in between we see an additional source. So this is the flaring state of Sagittarius A star.
JPL-COM, Chandra OC.
When the Chandra team downloads their data from space, they see it too.
Oh, yeah.
The X-rays show a spike that coincides with the Germans' flash of light. Genzel checks in with the Hawaiian team, but they're in the wrong time zone.
News from our colleagues, of course, telling us that they are a few hours further west. So the sun hasn't even set yet.
The Galactic Center hasn't risen above the Hawaiian horizon, and Gez has missed the flare.
This part kills me. Waiting.
But the next night, Gez finally gets what she's looking for.
Well, I like that image a whole lot better.
This is it.
Really?
Yeah. Really.
So in fact, we can see this flaring activity where we think we're seeing matter fall into the black hole. And just a few minutes later, it was absolutely gone.
This now you see it, now you don't flash of light is an explosion of energy produced when matter rushes toward the black hole and some escapes.
We were taking measurements and you didn't see anything from the black hole. All you saw was a star, and then bam, it was there and bright. And 15 minutes later, it was gone. So that was our moment to make the measurement, and it was extremely exciting to know that we'd actually been able to catch it.
The teams are thrilled to capture a handful of flares at the heart of the Milky Way, but they're just snacks. Nothing compared to the giant jets seen in distant galaxies. What's more, they're looking like rare events. There's simply not enough matter near our black hole to provide a large continuing feast. It seems, at least for now, the giant's plate is empty.
Our black hole had a wild teenage life. I'm pretty sure of that. It probably had jets. It threw lots of matter out. It had a grand old time. And now it's decayed into the old folks' home.
But what would it take for the monster of the Milky Way to come out of retirement? Could explosive jets of energy blast across our galaxy in the future? Tantalizing clues are turning up in the coldest place on Earth. A Smithsonian team is tuning into high-frequency radio signals from the galactic center. The best reception is at the South Pole. Not as nice as Hawaii, but the date is worth it.
There's some of the gas falling in toward the black hole in the galactic center.
Reading the radio signal, Anthony Stark detects just small amounts of gas feeding the black hole. Nothing too serious. But farther out, about 400 light-years from the galactic center, he can see signs of something much more alarming. A vast ring of matter is gradually growing bigger.
This storage ring then builds up until it coagulates into a single gigantic cloud of about 30 million solar masses.
When the ring reaches a tipping point, it will condense into a giant cloud, triggering a dramatic starburst event, a storm of stars forming and dying quickly. What's left of the gas cloud will spiral down into the grasp of the black hole,
which then rapidly spirals in and feeds the black hole in the galactic center, making the Milky Way an active galaxy.
When the feasting starts, the fireworks will be seen across the Milky Way. But don't bother marking your calendar. Dinner time isn't scheduled for at least 10 million years. The Milky Way will survive its black hole's upcoming feast, but it isn't likely to survive the threat further down the road: galactic cannibalism.
Our galaxy, the Milky Way, is not immune from these colliding galaxy scenarios. We've got neighbors.
2 million light-years away, our closest neighbor, the Andromeda Galaxy, is charging toward us at almost 700,000 miles per hour.
We're falling towards each other, and one day we will collide.
Knowing the galaxy's dimensions and the laws of gravity, scientists can predict how the clash of titans will unfold.
What our simulations show is what could happen basically in quite a few billion years from now, when the two galaxies will actually approach each other and merge.
The merger will take more than 2 billion years, while the galaxies circle and entwine.
Imagine what that might look like from another galaxy. They'll see two grand, beautiful spiral galaxies moving towards each other, slowly losing their shape. They'll see new avenues where stars and gas can funnel down towards this newly formed center, feeding this reborn monster.
The collision will send a blizzard of stars and gas in all directions. Some will shoot toward the crowded core of the new galaxy, spurring massive explosions.
In the process of merging, there will be a very strong starburst event occurring at the time of the merger, as all of the gas is being funneled towards the center.
Amid the turmoil, chances are our little solar system will either witness a spectacular show or be flung out of the galaxy into the voids of space. The Milky Way will be destroyed. But what about the black hole at its center? Most likely, it will merge with Andromeda's, a monster 50 times larger. Stars and galaxies may come and go, but supermassive black holes just get bigger. Once considered freaks of the cosmos, black holes are coming into their own, claiming their place center stage in a violent, changing universe.
As we forge ahead in trying to understand how we came into being and how all of the matter got put down in the universe, we can't leave black holes out of the picture, because it seems they play a fundamental role on very, very large scales.
Black holes not only wreak havoc upon the landscape in which they're embedded, they actively shape the landscape. So black holes are kind of the spice of the universe.
Black holes are a major player in the evolution of the things that light up our night sky. They are, in a sense, the secret shadows behind the walls of the galaxy.
On NOVA's Monster of the Milky Way website,